rise for the prayer.
கருவாக்கி உருவாக்கி எனையாண்டு காத்தருளும் இறைவா நன்றி. துணையாய் வருவாய், நேர்மறை உணர்வுகள் பெருகிடச் செய்வாய். உடலில் உறுதியை பெரிதாய் தருவாய். உனை உணரும் அறிவை என்னுள்ளருள்வாய். சுற்றமனைத்தும் காப்பவனே, செய்தொழிலில் ஏற்றம் தருபவனே, எடுத்த செயலில் வெற்றி கொடு, என் ஆற்றல் பெருகிட அருளை கொடு. கருவாக்கி உருவாக்கி எனையாண்டு காத்தருளும் இறைவா நன்றி. வல்லமை தந்து நீ வளர்ச்சி கொடு, அகத்திலும் புறத்திலும் மலர்ச்சி கொடு. வளர்ச்சி கொடு, மலர்ச்சி கொடு, வளர்ச்சி கொடு, மலர்ச்சி கொடு.
Good evening, everyone. It gives me an immense pleasure to be back again. We meet every month regularly. A very special warm welcome to our guest speaker, Architect Sushant from Rat Lab. There is something common between both of us. Can you guess anything? That we'll come to next after that. So basically he has twin boys, myself also, same. He's born on 16th, that is this month, his birthday. So belated happy birthday to you, Sushant. And if you can see number 7, so 6 plus 1, 7 again. He's married, his partner is also an architect. So lots of common things. And let me take you to our previous events, what we had done. So I just want to know, I'll just tell you that out of the box series 1, which was, I think we didn't have, it was a time constraint. So that's why we couldn't play the video. So I'll just play the video. Before that, can we have the next slide? So few of our members had visited LTEXL, and we saw their showroom. And there was a lot of knowledge sharing as well. So can we have the AV, please? So after that we had NatCon 2026 where 20 of us had detailedly presented to the National Executive Committee who had come to Coimbatore, and we went to all the places, 3-4 different places. Can we have the next slide? Yeah, you can see that. Next. So this was in Merlis. We went to PSG. We received them from the airport. And we had a meeting of NatCom, which was called as a Sangamam. And we had presented, and can we have the next slide? The people who had presented. Can we have the AV, please? There are 2 AVs of this. had done, though we couldn't go through it, we were selected as top 3 in entire India, you know, and we lost by a few votes, but nevertheless, no problem, no hard feeling. We try next term again, right? So now we had this Design Arangam 4 on 20th May at Radisson Blue as well. Architect Deepen Gada, we were from Srini's period, we were like after him. It took almost 1 year to catch him, though he is past IIID chairperson of Baroda. So next. So this is few of our event photos. And can we have the AV please? Today, seeing this IIID family again, gives me a lot of strength, positivity and energy. So coming back to Design Arangam 5, I met architect Sushant long back and his presentation was really nice. So then I decided that I should call him. So now, can you go to the next slide? So what happened was now we went for Hyderabad for the joint NEC, and there was a CEP program as well. From Coimbatore Center, architect Anjanesh sir had registered and he had visited. And I request Anjanesh sir to come to the dais, please. That's Anjanesh sir for y'all. So is this okay? So again, AI, So can I have the next slide? So is it okay? Yeah. So everything is there. Is it okay? Next.
Good evening, everybody. Okay, I had the opportunity to go to the NIFT Hyderabad for the CEP 5 on, I think the topic is Poetry of Light. We had a great seminar and it was presented by lighting designers who are very famous and had done wonderful projects throughout India. And we had, of course, the person in black who stands to the left is architect Shyam, and after him, the bald head is lighting designer Linus Lopez. Linus Lopez is a very well-known name in the world of lighting in India, and he's done lighting for a lot of museums, and he showed us a lot of projects right from Delhi, Mumbai, Goa, and the architects whom we worked with, the artists whom we worked with, the sculptors whom we worked with, curators, etc. So it was a very enlightening experience with all the 5. And apart from that, he calls himself the disciple of light. Okay, because he says with every project I keep learning. So very humble, very down to earth, grounded people, all the 5 people. And then we had Kunal Shah, who was from Hyderabad. And he's done interiors for a lot of restaurants. And you know, Hyderabad is a very lively place. And so with a lot of projects and Amravati also growing nearby, he's got a big lineup of projects. So he was sharing his way of doing things. So he always insists on a mock-up. And he always tests what the software does with regard to the field, that is a site. And he tries to improve the situation on the site. So that's one of his ways of handling projects in lighting design. And then we had Lakshak Agarwal, who was also from Hyderabad. In fact, he's done some projects in Coimbatore. He said he's done a coffee shop at Navindya. And he calls his firm the love of light. Okay. And in his approach, he was teaching us about CRI, which is color rendering. And he talked about how lighting companies were initially a little hesitant to share the CRI data of lighting, and now they're very forthcoming. And he talked to us about TM standards, which are international standards, followed by US, Europe, and he was recommending that we follow that in lighting also. And after that, we had Dr. Amardeep Dugar, who was from Chennai, and he was very interesting because he called himself the doctor of light. And he was talking to us about lifestyle, what is important in lifestyle, and how light plays an important role. So he started with daylighting, and ultimately he showed how he works on his interiors. So everybody has expectations. The client also likes to play a role in lighting and every part of design. So he was involving us in every way through the design process, how he involves his team and the client. So, there were always trial and errors. So sometimes he always, educates the client, like we all do, as to how to, keep up with time. And sometimes, you tell him stories to let them know how things work with the designer. So that was his approach. But he's been hands-on with a lot of colleges, which is like RV Bangalore, SAP Chennai, and other premium colleges in Tamil Nadu and in south of India. So he was talking to us about workshops which he had worked with students and how their knowledge level improves and all that. Then finally we had Sheila Trivedi, who's also a IIID member and who's a past chair of the Rajkot chapter. And she took us through, how light communicates, like how we see a traffic signal and how that communicates with the public, and how does lighting communicate in interiors, and how do we layer the lights to make it more interesting, whether it's an interior space for a restaurant, whether it's a classroom interior, or it's for a retail space, and how color and lighting play a very important role in, every interior. Then further on down, she moved on to urbanscape interiors. And in urbanscape interiors, she was telling us a very disturbing trend, like saying the present upcoming generation like a lot of lights, and there's a lot of lighting being done unnecessarily. So that's what she was trying to sensitize us. She says the dark is also important. The darkness is also important for the human eye and the human body, because you should allow it to rest. And it's not that always that the city should always be 24 hours active. There should be a complementary role to human lifestyle and with also to relaxation to nature. So we had a very interesting time with all the 5 designers, and that quite took us about 4 hours with the whole presentation. And then we had a lighting workshop after this presentation with a tea break. So we were divided into teams of 15 members, and that was a huge gang, so you can see. And there were about 85 participants, including the host team of Hyderabad. So we had Manoj Vahe in our team, and we were given this big main courtyard of NEFT. And we were asked to design wherever we could. And imagine, 15 of us getting together, and the time was about 3 hours. That was the time given. And we had to have a working dinner. And, 15 of us, and we were discussing, each one giving an idea, each one telling what they wanted or what could be the best thing. And it carried on, and 45 minutes just, elapsed with just discussions. And suddenly it started drizzling. And we took cover, and we thought we'll split into 2 groups or smaller groups. So me and Shyam, we teamed up. And we were about some cardboard boxes, about 12 of them. So we were just given that, and we both of us took it together. We tried to do something, and power went off. And the idea of the lighting workshop was we could choose any light from what Futura could give us. And imagine 85 participants, they could choose their lights, and they could use it for their, whatever they wanted to do for the workshop. So we had 12 cardboard boxes. And because there was a power cut on and off, we started doing something, and then evolved to making a human or something close to a human. And the extension boxes weren't enough. Again, power went off. Then we went off for dinner. Then we came back, and we did this guy with ultimately a ball-like structure. You can see, I think, on the right extreme, or even the photo, which is tall one with me and Shyam. So we did that, and again, we couldn't place lights in the courtyard because there was no, rain was on. So we put this structure under a street light-like thing, and we made the idea saying that it's a football player or a fan playing under the street light. Okay, and we were the only 2 to finish, and we were the only 2 to, do with whatever was given. And finally, we made the lighting experts also see what we had done. So more of enthusiasm, I would say, from both of us. And we were encouraged. So that's what really happened, and it was an enlightening session with all the 5 lighting experts. And we look forward to more participation from our IIID members for the upcoming CEPs. Thank you, all of you. Thank you.
Thank you, sir. There was a joint NEC 3 where myself, architect Rajgopalan, and architect Nagapan, we had gone over there. And this was the joint NEC. Can you have the next slide, please? And there was an exhibition as well. So we visited all the stalls, and I was one of the juror where I had to select and give marks also for each of the stall. And you can see that was the last, you can see that was a model which was done by the students. So there was students' competition as well. And these are the chairpersons across all 35 chapter centers, and now one more chapter has been added, that is Nagpur. Kanpur. And now there is NatCon 2027 in January month. So I request to play the AV for that. This is a teaser for that. As well. That is what is NatCon. So can we have the video AV please again?
For past years, many, we learned, we created, we built, and somewhere along the way, we became comfortable. What worked then and yesterday worked again and again. until now. The world changed, quietly. Then suddenly, tools began to think. Machines began to learn. The climate grew restless. And certainties became questions. Our students prepare for professions that may exist or exit. Our knowledge may no longer be enough. And standing at the edge of everything we know and everything we don't. One question emerges: what next? Perhaps this is a moment for reflection. What shifts? What no longer serves? What must change? Because yesterday's methods may not be enough for tomorrow's realities. Won't a few things still endure? Human stories, nature's wisdom, arts, crafts, and culture, context, community, collaboration. Technology may accelerate, but meaning is still made by people, and relevance remains the key. The future is no longer coming. It is already here. New tools, new pressures, new opportunities. The unknown rewards the prepared. Those who learn early will lead later. The lesson of readiness. And then comes the most important question. Not what we can build, but what we are building towards. How do we remain human in a digital age? Transform challenges into opportunities. How do we design not just spaces, but possibilities? How do we shape a future worth inheriting? That is renewal. For over 50 years, we found answers that shaped our present. Today, it is our turn to question. What shifts? What endures? What awaits? What inspires? And above all, what next? Navigating the next in design.
So it will be 7, 8, and 9. We all will be traveling. We'll be sharing the Google form as well. And after that, we are planning to go. We'll be there. We'll be planning to go to Charminar and then Film City and other places as well. So that will be 10 and 11. That's optional for our members. I request everybody to register for NatCon 2027. Can we have the next slide? This will be the thing. So it is basically for members, early bird offer that it is 5,000 rupees for registration. So when we have curated this entire event now, it is roughly around 30,000 rupees it comes if you are going in train for the entire trip. And those who would like to come by flight, it will be 40,000. And people who want to travel by their own are welcome. But registration is mandatory over there, which we have to do for early bird, which will be over by next month. So I request everybody, we'll be sharing this. Architect Nagapan will be sharing it in the group. So request everybody to join. This is our event. Though we didn't get NatCon in Coimbatore, we will see that next term we get it definitely. I request Architect Prithviv to introduce our guest speaker. That's Prithviv? No. And we have the next. Yeah. Now this is you, right? Come.
So, good evening, everyone. It is my privilege to introduce architect Sushant Verma, an internationally acclaimed architect, design technologist, educator, and a founder of Research in Architecture and Technology Studio. A graduate of the prestigious Architectural Association, London, with a master's degree in emergent technologies and design, architect Sushant has also worked with the globally renowned Zaha Hadid architects. Over the past decade and a half, he has established himself as one of the leading voices at the intersections of architecture, technology, and innovation. As the founder of RATLab, he has transformed the practice of computational and parametric design in India. creating a studio that delivers cutting-edge work in architecture, facades, interiors, urban design, and interactive installations. Under his leadership, the RAT Lab has grown into an internationally recognized design practice with projects and collaborations spanning India, Europe, the United States, and Asia. Behind professional practice, Architect Sushant is developedly committed to education and innovation. Through initiatives such as RAT Lab Education, Smart Labs, and EduLab India, he has empowered thousands of students and professionals to embrace emerging technologies in design. His contributions as a TEDx speaker, author, mentor, and mentor of change with NITI Aayog's Atal Innovation Mission continue to inspire the next generations of innovations. His achievements has been recognized globally through prestigious honors including the Max Schindler Award and recognition as the finalist for the AIA Emerging Leadership Fellowship. His work has been exhibited and published across major international cities, reflecting his commitment to pushing the boundaries of design through research, technology, and creativity. Today, Architect Sushant Jay stands as a pioneer who is not only shaping innovation spaces, but also redefining the future of design education and technology-driven architecture. Please join me in warmly welcoming Architect Sushant Jay, Amita Verma with a round of applause. Thank you.
Thanks. Check. All right, thanks a lot. Thank you everyone for having me here. Thank you IIID Coimbatore. Thank you to Ashish and Srini to invite me and make me a part of this wonderful conclave that you are doing over here. So let me just get the clicker just to make sure that I'm able to run through my slides. And I've done hundreds of talks and I almost have 100% record that there's some kind of a technical failure that happens in my talks for some reason. Yeah, so that's kind of contradictory to what I do. And before I start, I'm just going to be talking about quite a few complex things as well. So I want to make sure that everybody understands complexity, everybody understands technology, because we're going to be talking through the language of algorithms. And algorithms can be very, very complex. So may I ask you, how many of you think you are technologically advanced or enhanced, like in some way or the other? Can I get a show of hands if you think you're technologically advanced, or as designers, as human beings? Very few. Really? I thought all of us have smartphones with us at least. Yeah, so we are technologically advanced. How many of you understand algorithms? A bit. We've heard about algorithms, right? So obviously it's a complex term, and let me give you an example through a very interesting tool that I have over here. It's a simple puzzle, like most of you have seen this. It's called a Rubik's Cube. Anybody here who knows how to solve this by any chance and can teach me perhaps? No one? Oh, come on. So it is basically, it looks very chaotic, but this is a very good example and an analogy of an algorithm. Now this exactly is an algorithm. How you solve this is something which is not that simple or straightforward, because if you just look at it and look at the permutations possible of a Rubik's Cube, that's the number over there, the staggering number. It's a big number. I'm sure most of us can't even get this number right when we read it, right? So it is quite complex, and a couple of weeks back I thought, let me try to, I talk about algorithms, I learn algorithms, I teach algorithms, but I can't solve this algorithm yet, right? So I thought, let me try to understand how complex this algorithm is. If I can relate to the kind of algorithms that we work with in design and architecture and our practice, which I'll come to in a very short span of time. So, yeah, so, but a lot of people can solve it, as I mentioned. Even a lot of kids can solve it. I'm surprised actually no one here knows how to solve this and can teach me. But a lot of kids can also solve it because it is a system. It is a step-by-step process to lead to a solution. So basically it's nothing but a problem solving. So this is one kind of problem solving that we're talking about over here. Sorry, I'm just going to have a little trouble finding the right signal for getting my slides in place. But yeah, I think I got to remain closer to the system over here. So yeah, so a problem, like I mentioned, is not chaos, it's the unsolved logic. And every complex system has an algorithm inside it. And I want to talk you through about this using this kind of a prop that I have over here. Currently, I don't know how to solve it, but I use it as a tool for fidgeting. Whenever I'm nervous, whenever I'm anxious, whenever I need to calm myself, my hands keep on doing this. That's pretty much what I do right now. Right, but what I try to do, I try to actually look into how you can solve the algorithm. And as if you just Google it, it says it's widely perceived as difficult, but it is actually a matter of memorization and logic. That definition got me very intriguing. That if every problem we can solve by following a sequence or by logic or by memorization, then it's something that every human should be able to do. But yet we are not able to do that. And it's something which is a series of moves designed to manipulate certain pieces, but this is what the moves look like, by the way. R, F, U, clockwise, counterclockwise. If I start to just observe this, and try to follow these steps, I don't think anyone over here would be able to, align the steps if I try to go with the steps like this. I don't know. So it's going to take its own time and shape, basically. But it definitely gave me an inspiration, and which is why I love to talk about the world of algorithms. Now, what exactly is an algorithm? Let's not complicate the word. I know I've scared you enough in the first 5 minutes to give you very complex jargons, but what exactly is an algorithm? What we follow an algorithm every single day. We wake up, we brush our teeth, we have a coffee, drive to work. That's a simple algorithm. We follow it every day. We repetitively do that every single day. And that's exactly what the algorithm is inbuilt within us. So algorithms are not very complex. It's basically a problem which is solved through simple steps and a step-by-step solution. So let's simplify the term algorithms. And I want to talk about how does it feel to be designing with algorithms, because this is exactly what I do. So my name is Sushant Verma. I'm the co-founder of RatLab Studio, also the studio director of Smart Labs, and I run this practice called RatLab. And no, we have nothing to do with rats or different animals. RAT stands for Research in Architecture and Technology. Let me set that clear as well, because a lot of people tend to confuse. We still get calls thinking about that we are a laboratory which deals with animals and all sorts of things. Funny stories for another day. But yeah, that keeps happening. But how do we do that? So I am surrounded by algorithms. We do art, we do facades, we do different kind of architecture. We are also teaching. I'm going to talk to you through all of these things step by step as I unfold my journeys. And my journey is nothing short of complex, I would say. Nothing short of being a Rubik's Cube in itself, where a systemic approach is required. So I would actually compare myself with a Rubik's Cube and a building, basically, and how it all sort of comes together, which is where I compare it with an architectural project. A Rubik's Cube has solutions, it has rules, it has parameters, we generate different possibilities, we evaluate and we design the future, which is exactly what we try to do with the buildings as well. Okay, so the journey started back in the day when I decided to go for my master's, and how I started to got a bit of a signal issue with my slides, right? So my aim as a young designer at that time was to bring parametric design to India, and how it started, which is what I'm doing right now. But how it all started was basically, currently, of course, the parametric movement I'm talking about is we're building projects across India. We're doing facades, we're doing sports projects, we're doing religious projects in sacred spaces. We're doing some high-rise skyscrapers. So these are few projects in Tamil Nadu, Delhi, and Varanasi, which are all very different and unique in itself. And everything has some sort of an algorithm behind it in some way or the other, which is what we're trying to be using. But how it all started for me as a journey was I was born in Delhi, moved to London for my master's at the Architectural Association. After that, I moved to Los Angeles and made my way back to India. My partner, Pradeep, who co-founded RatLab with me, is from Bangalore and he moved to London. Again, we met there during our masters. Later on, he went to Shanghai to sort of pursue his robotics, which is what he's doing. Moved to Germany and then London as well. So we've had a fair bit of a global understanding and experience and exposure over the years, which has really taught us a lot of things. So I studied at the Architectural Association London, a prestigious architectural school, which sort of exposes you to a lot of things about technology, about design, about architecture, how to solve problems. Not a very easy place to survive in, but nonetheless, I did survive. And after that, I went on to work in a robotics company, a company which used to build facades using robotic arms. It was called RoboFold. And then I started to work at Zaha Hadid Architects, which was one of the game-changing and life-changing experience for me, I would say, because that's pretty much where I understood where I have always wanting to be and where I was belonging at that time. And ZHA had a huge influence on me. And whenever I was engaged in projects of different kinds, I used to think that back in my country, in India, nobody is doing something like this. There are no design conversations like this. And at that time itself, I thought that someday I would want to go back to India and practice all of this in India, hopefully, and teach people how to do all of these kind of things, how to think differently as well. When I went to Los Angeles, so after my work in London and at Zaha, I moved to Los Angeles where we were awarded a residency. Pradeep moved from Shanghai to Los Angeles. I moved from London to Los Angeles. We were there for 6 months. We worked with different artists, architects, designers, did some exhibitions and designed a facade which could automatically change shape using the sun's heat, basically. So it was very futuristic at that time. And even now it would sound very futuristic. But this is pretty much what we were doing. After that, there was a conscious return, like I mentioned, to come back to India. And we had a mission to spark a cultural shift towards design technologies. And how did that unfold is a story in itself. But when I moved back to India, things did not look very well. It felt like I'm in a place where I'm the Stone Age man trying to work with technology and trying to talk to people about technology. So it was more about flirting with technology, as I like to call it. And it was a very common thing at that time that the term parametric design was very popular. And I was trying to correct people that it's actually computational design. And people used to ask, like, how can algorithms design buildings, So those were like very normal, excuse me, very normal questions at that time, that how can algorithms design building, right? A question that we ask now is how can AI design buildings or spaces or architecture? That's a very relevant question. So quite an interesting debate to get into. But yes, to prove the point, we thought, okay, we have to move beyond the aesthetics. We have to work on a system. Again, I'm using the terms associated with an algorithm, a system. Like, so we have to create a system which can help us design better, which is more efficient, which is more effluent in some way or the other. And to do that, we chose the route of building an ecosystem around it, where we started to teach about technology, where I started to talk about technology. We started to create a lot of groups and communities amongst designers, students, and professionals alike, and started to talk about technology, because that was the start of the change. How do you bring about a change in the system? You just can't go and say that, okay, let's change it and tomorrow onwards we'll start to think differently. That's not how innovation works. So innovation works in a very different manner, where we have to put a seed basically before it actually becomes a plant, or a tree rather. So that was the start of building an ecosystem. And as the ecosystem started to evolve, we started to do a lot of workshops. We did about 150 plus workshops in the initial couple of years. We moved city to city. I moved from New Delhi to Mumbai, Bangalore, Chennai, Chandigarh. We did a 5-city tour at that time. This was back in 2015, I remember. And it was a very interesting experience for me, because I got to train about 150 plus students of design, professionals and students who had not graduated yet, to teach them and expose them about technology. And which is how Rat Lab Education was born. So we actually started to associate one of the vertical as Rat Lab Education, where our mission was to educate people. And that brings me to the second chapter of my conversation today. How many of you have seen Durandar? Again, very less hands. What are you guys doing on weekends? Yeah. So yeah, as you've seen the movie, it's built in chapters. I'm trying to show you my journey in the similar format. So the chapter 2 is academia. So where I talk about this pillar of our system. How it started when we were doing workshops, I was always questioning that how smart is our education? And that was a very good question to ask ourselves, because I realized that, 150 years back, our classrooms pretty much look like this. And 150 years ahead of the time as well, the classrooms still look like this. Which is what I started to question, that how smart is our education? We are taught in the same way, we are learning in the same way, we are teaching in the same way. So how are we evolving as a society, as an education system? So which is what became sort of a mission for Rat Lab Education. And we understood that we need to become more collaborative. We need to make sure that people come together, talk to each other. It is not just one person sitting behind a desk and looking at a tutor teaching. So which is what we were trying to inculcate into our academic studios at that time. And then we started to do a lot of workshops. This is a workshop from Taiwan, which we did in 2014. That's a workshop in Delhi, which I did in 2016. And here we were all teaching about computational design. Computational design is basically using computers in a much more powerful way to help you design spaces. Now these spaces could be architecture, building, spaces, art, objects, anything basically. And we moved city to city. We had some computational design tours. We worked with a lot of institutions as well. Working with institutions was not easy. Nobody was ready to change. So we started to create our own system. We created a school in parallel to teach people, which was open to all. And there were independent workshops that continued to happen in different cities. And that went about to create some work by the student. This is all works of students who had no experience or exposure in technology or any kind of advanced techniques of design. And they all started to come together. So we started to build this community of workshops where we produced some very exciting work, some installations, fabrications, a lot of teaching happened. Pradeep also used to come down from London, teach about robotics. And all of these were sort of works of students done over the years. And then suddenly, as we were questioning about how smart is our education, we started another laboratory called Smart Labs. So we started in 2017 as 3 years before the pandemic. Now the reason I say that 3 years before the pandemic, because when we started this program, we made it into a hybrid program. A major part of that is going to be happening online. A lot of it was going to happen offline in studios. And interesting fact, it started in Coimbatore. So the first batch of Smart Labs, now we are 12 batches graduated already. The first batch started in Coimbatore, and then it moved to Chennai, and then moved to Delhi. And then we kept on doing these programs where a lot of people from around the globe also started to participate. And over the years in Smart Labs, we are moving to Smart Labs 13.0 now, we kept on evolving the pedagogy of how we teach about technology. And that became a very important aspect about how we run Smart Labs as a studio. These are some glimpses from different studio sessions where we talk about fabrication, we teach students about technology. There is digital fabrication happening, there is an integration of AI also happen. We 3D print things, we laser cut, we fabricate things, we do a completely hands-on set of workshops that we do, and we teach them for a period of 6 months to train them about technology, and most of them end up mastering the tools in this period of 6 months. So this was all started after doing some shorter workshops, which we ended up, can you just press to the next slide? Yeah, that's fine, thanks. And there were very inventive times as well where students, this was a second year student of design, who ended up creating this system and interaction with the computer that your hands movement using a leap motion device is actually able to move a geometry or a surface. Now this is where we saw that our students are also getting very innovative and inventive in nature, and which is where we saw the success of the studio as well, that we are able to inculcate about using technology to these students who could actually produce installations. We did some exhibitions. Interactive design was a part of the module as well at one point, which people were trying to solve. Because the larger message that we were trying to do was that when education failed technology, we revived education, which is exactly what we were trying to do. And silently and efficiently, I would say as well, we were building a school in itself. And these tools allow you to design, to evaluate, to manipulate, do a lot of things which we never thought is going to be possible. So it's about giving the access to the right people in the right manner and create the smart education for smarter designers. And these are some glimpses of the studio from different years where we done installations, students coming from different backgrounds, coming together, learning to collaborate, learning to present their works in the right manner. All of that sort of happens across 6 months. I have also slowly been documenting my journey as well, which was done through a recent book. This is my second book, Parametric Minds, where I talk about innovation and how we create empowering design pedagogies to change the mindsets of people. So this was recently launched as well. We had a book launch in Delhi that was happening. The renowned entrepreneur Ankur Warikoo has also sort of given a blurb for the book as well after reading it. It's kind of available on Amazon and different platforms now. At the same time, how else I've been trying to make impact is by speaking at various forums, which I get invited to, such as this one. So I've spoken at TEDx about 4 times. There have been 4 TEDx talks that I've given over the years, which are there on YouTube, and has reached out a decent amount of people to make an impact, which is what I've been trying to do. To how to create that impact and reach out to more and more people. We're also building our own integrated AI in the studio. It's called labrat.ai, which we use for training different models to design, to assist in designing in different ways. So that's another part of what we're doing. The next chapter I want to talk about the lab, which is Rat Lab, which is a large umbrella under which we operate with different verticals. And what we've been doing over the last 10 plus years of working and flirting with technology, we've delivered more than 100 innovative projects, I must say. I don't think there's any single project which I will not call innovative. Each project is innovative in its own way. It may be because of the kind of how we are responding to the brief. It may be because of the design language. It may be because of the environmental response that we are able to bring in. It may be because of the kind of impact that we have been able to do. So there have been different kinds of projects. It's very difficult to sort of pinpoint a few of them, but I'll definitely give you a glimpse of a few. So there have been installations at the Bangalore airport, the Kochi airport as well, a few sports complexes, restaurants, facades, furniture, different scales, different mediums. But what we've been doing in these last 10 years is building our expertise in one of the core expertise that we have is facades. So we design a lot of facades, and all of them will look extremely unique in its own way. And there have been algorithms behind these designs as well, which is what we try to use for. Behind the design part, there is a lot of value engineering. When we do a facade, we have to understand the value engineering part, the structural understanding of the facade, the complexity of the detailing, how does it respond to the environment. All of these things are done by various tools that we have created over the years. These are a few more glimpses of the projects. And I also want to tell you that most of these projects, the most innovative part is that they are cost effective. They may not look like cost effective, but they are all cost effective. That's a challenge that we always get. Almost every single client comes to us, they see a design, they see it's very interesting, looks complicated. The first question is it going to be expensive? So the biggest challenge that we always have is how to cut down the cost, how to value engineer it in a way to make it cost effective as well. So that's always a part of the design process itself. And all of that becomes possible by using technology, such as design technologies like computational design, parametric design, algorithmic design. This is Tweening Arches, one of the facade that we built very recently in a portfolio where we designed and built also. We executed the facade as well. We went into execution of facades a couple of years back because we realized that whatever we were designing, the regular fabricators and conventional vendors were not able to execute them at the right cost. So we actually ended up into execution as well, and now we work with different architects to help them support their execution as well and making it more unique and cost effective both. We look into environmental parameters. For us, the performance comes first. It's not just the aesthetics, which otherwise parametric design is mostly known for. And you can see these interesting, unique facades. Just soak in the iconicity of this, of where it stands. What kind of context it has, and you can imagine the kind of impact that something like this has managed to create. This is a commercial complex which we're building in Rewari, which is a satellite town to Delhi NCR. And again, going to be a global center for making something very, very unique. Ripple geometries, mostly modular, 70% modular, 30% bespoke in nature. This is another metal facade that we recently built, designed and built. You can see glimpses of the same as well. So at large, what we are doing as a system is we're working actually on small, medium, large, and extra large scale, where the projects are actually focused on different scales and aspects. And when we design, when we create these scripts, as we like to call them, as an algorithm, they just don't make forms, they solve problems. So our every algorithm that we design for a building is to solve a problem. So the kind of tools that we've ended up creating over the years help us in prototyping, feasibility analysis of different times. So there are climatic tools which help us assess a building skin, facade, or any project that we have. Then there are other different kind of urban tools which allow you to understand visibility, which allow you to understand building visibility, building dynamics of different kinds. All of these tools are deployed on different projects, which takes me to the next chapter, which we call as art. So talking about the smaller scale, what we're doing in the realm of art, so a little less technical as facades. So we do art installations. We have a vertical called Art Lab, which was sort of grown out of the Art Lab studio as one of the vertical, where we also work with a lot of other artists as well. So we do art installations, which are mostly parametric art installations, where we are parametrically designing an object, be it a sculpture, be it a wall art, be it a chandelier, be it a back wall. All of that is done at the studio. Wherein we have deployed different materials, and all of these forms that you will see, now this is carved out of stone, for example. And you can see the texture of the stone. There is an inlay of golden mirror in the center. And it's a backlit stone as well, so you can put light over it. And this is going in a lot of places where we work with interior designers to help them make feature pieces or signature pieces for their projects. We've also been doing sculptures. This is one of the butterfly installations we did. A larger version of that was featured in a couple of galleries in Delhi. And this is now installed in the Kochi airport. So this is a permanent piece at the Kochi airport made with stainless steel, where you have about 200 butterfly in different angles floating to make the surface. But how did we get the angles and compute the directions of each butterfly? That's where the algorithms come into the picture. And that is usually behind the scenes. We're also doing different kind of unique furniture, coming up with a gallery as well, which is housing pieces of our own lab and other artists as well. We recently also did these parametric columns for a banquet in Gujarat, in Vapi. This is what it currently looks like. Then we've also done like few different wall art features of different kinds in different spaces, and now coming up with a gallery as well. And these are a plethora of different unique installations. There are drape-like installations. There's a chandelier, a couple of chandeliers. We worked for Kohler Experience Center in Hyderabad, made a full parametric wall art for them using sculpted wood. We've done a lot of furniture pieces, couple of things in Chandigarh as well with this Corbusian hand kind of a thing. And that sort of brings me to the next chapter, which is facades in particular, which is, like I said, one of our main expertise. So moving to the larger scale beyond art, so design isn't what you draw, it's what you debug. So basically when we design facades, it's mostly we're trying to solve a problem. So what is the kind of problem that a facade faces? Basically facade is an interface between the interior and the outside. So what it has to tackle is the environmental dynamics that you see over here. So before we start designing something, we actually look into the radiation. We look into the daylight values inside on the floor plates. That's where the design starts. And when we start designing, it usually starts from a sketch. And I always have to sort of mention that because knowing that we come from a world of technology, one might think that the computer helps in designing all of this. Computer only helps. But you are the designer which sort of designs all of these things. This is a recent residential project as well, which we again designed and built uh, in somewhere close to Delhi. This is another residence which is under progress right now. And mostly whenever we do residential projects, we try to do a bit of uniqueness in the facade without really affecting the architecture of it. And this is another such example. This was an office space that we designed and built. This is the Kohler Experience Center, which was actually a huge 60 feet by 25 feet wall, which was made entirely in wood, sculpted wood. So every single piece there was a back wall being made, and every single piece had a numbering system and a sequence which had to be put into each of these numbers like a jigsaw puzzle to be able to create this entire wave-like form. And even if you miss a single piece out of these thousands of pieces, your entire form goes for a mess. So that's something you can't afford to do. So that's why your systems have to be very much in place. So when we create designs like these, our systems have to be absolutely strong. Then moving to other scales as well, this is again the commercial complex which we're building in Rewari, which again has a unique facade. We also had the pleasure to contribute to one of the key infrastructure projects in Delhi, Bharat Vandana Park, which is basically has these 9 pylons and a sky bridge. So RCOP had designed this project from Delhi, but when we got associated to the project, we were given this very, very complex looking form, and we were asked to parametrically model so that each part of it can be fabricated and executed by the local contractor who is appointed for building this infrastructure projects. So it was a government project, and it had its own sort of a timeline and constraints that we had to work around with. Excuse me. But when we had to model this, it was quite a bizarre job, and I think this was one of the most complex parametric models that we built up, and this is now being constructed as well. We're also doing this project in Varanasi, where we're making this unique global destination for Varanasi as it's coming up with the real estate is changing. So we're working on this project where we've done the facade and the landscape of it to actually make a very, very unique kind of a parametric building, but done in a very, very cost-effective manner. Because the intervention of the facade is not to make a second skin, but to change the design of the material of the balconies to make the form pretty much more interesting. A couple of walkthroughs as well. This is pretty much what it looks like. See, when I get fidgety, I start to take some steps on the algorithm. All right, so a couple of more facades which we've been doing over the years of different kinds. Hyderabad, Hong Kong, Gurgaon, Tamil Nadu, Australia, Hyderabad again, Kolkata. So again, we've been working all across India and outside of India as well. And we also go across scales. So we also worked with a fashion designer and collaborated to design this 3D printed wearable, which is again, for us, it's same as designing a facade. And that's why I'm showing you something of a different scale altogether, where we were controlling the transparency versus the pattern of a fabric or a dress, which has to be 3D printed, to create this interesting collaboration, which was later on used in a couple of fashion shows over there. We also designed a trophy for one of the Wade Asia, which was a women-centric awards. So when they had started, they had asked us to, sorry, can I go back? Yeah. So we had to represent women design. So we actually took it as a celebrating women and the W to make a design. And when we were designing it, for us, we were designing a skyscraper. So that's what algorithms and technology allow you to do. You operate at different scales using the same system. This is in Tokyo, a shopping center skin that we were doing. This is a cricket stadium collaboration we did for Australia. We designed this swooping skin, and the whole roof structure was actually was filled with solar panels. So we basically had to design the curvature in a way where it could be optimized to maximize the amount of radiation receiving so that you can charge the solar panels much more efficiently. And the next one is a temple project. It's a Sai Baba temple, which we were a part of. We worked with a prestigious firm in Chennai, Shilpa Architects, where we collaborated. They were doing the urban planning and the master planning of it. We were designing this main temple architecture. And it was born out of a lot of Vastu principles, which is quite interesting. And it's got a very interesting story to it. And you can see that everything is around 11 sides over here. So there was a big constraint the client came with, that he wanted to use the number 11 apart from other Vastu and numerology principles. And we started to integrate and understand what all can we do with number 11. So we ended up working with a geometry called hendecagon. Hendecagon is an 11-sided polygon. And we started to create forms, mathematical formations, what all we can manage through a hendecagon. And we ended up designing an algorithm which could help us design all of these forms. And then we later on structurally started to optimize these forms of what works best for us, what does not work best for us. And all of that became a revelation into something like this, which had an oculus at top, and it had 11 sides, 11 columns going up on top to make this entire structure where the deity is right at the intersection of the 11 sides that are coming in and converging. And how we infuse technologies, we also built an augmented reality tool at that time. This is back in 2018 or 19. So at that time itself, you can imagine the technology was not very popular, but we were able to make this to actually create the experience while we were explaining this to the client as well. So these kind of tools and interventions become very, very important. So when we're designing something, how we present it, how we visualize it. So we try to use tech in different spheres of our work as well. This is a recent project of ours which we are doing in Delhi. It's by ISKCON Temple. ISKCON temples, as most of you would know, are located in different parts of the world. So we are reinterpreting Krishna's story and narrative through this temple project. Can you go back on the slide, please? There's a video, I think. There's a walkthrough. Can you? Okay, let me do it from here. So you talk about technology, and technological lags are always bound to happen. Irony of life. Are you able to move to that slide manually? Okay, let's wait for it. I think it's a heavy video. It might just hang a bit. You might want to exit and get back on the same slide. Give it a minute maybe. Yeah, lots of videos. I think it's lagging a bit. It was working fine when we checked. You want to exit and restart from that point? Yeah. We'll take now. Ah, okay, sure, yeah. So I think while we wait for the lag to happen, we can probably open the stage for any Q&A in case you have any questions so far. It's a complex presentation. There's a lot of things that I'd like to put up in different layers. So until now, if there's any questions, I'm happy to take that up while we try to sort this video. Apologies for the technical glitch. Anyone having? Yeah. So the primary tool when we talk about, so technique, we use computational design, what we call it. Also, we don't call it popularly as parametric design. Mostly the tool that is used is Grasshopper. And within Grasshopper, there is a lot of coding that is usually done. So coding could be through Python, C#. These are various coding tools. But it's mostly Grasshopper, which operates as a plugin into Rhino. Yeah. Any other questions anyone has? Yeah.
So Grasshopper is something you use to design exactly, right?
Yeah.
For analysis till execution, what other tools do you use?
So again, there are plenty of things. Grasshopper is one of the key platforms which allow us to design. But apart from designing, it also allows you to evaluate as well. So there are a lot of other plugins in Rhino, for example, Rhino Vault. There are structural analysis tools in Rhino, which we end up using. But within Grasshopper, we can write any kind of algorithms to solve a problem. If we are solving an environmental problem, we use a tool called Ladybug. Ladybug is a plugin within Grasshopper. Then we use a tool called Kangaroo. There's all these animals somehow associated with RATLab. And we end up using that.
So the value engineering part is still covered using plugins in Grasshopper?
Yes, yes, using it within Grasshopper itself, yes.
Okay, so from till what I've observed, it seems like there's a lot of metal involved. That seems like a major material. Is there, did you get to explore with any other material? I saw wood in few places.
Right, so when you look at facades, mostly you will see metal because it's one of the most versatile material to give form to any kind of a shape or a geometry basically. But we do use FRP as well. We do use different solid surfaces, stones as well when we do facades. When we do art, we are working a lot with wood, different kinds of wood as well, pine wood, rubber wood, depending on their grains, birch ply, metal, of course, aluminium, MS, stainless steel, plenty of things. In fact, I'm glad you asked this question. So for us, material is very secondary. You know, as designers, as architects, as artists, all of it coming together, we always think about one thing, which is geometry. And if we're able to decode the geometry, rest everything else follows, basically. Material is secondary, a second layer to it. What all material is it possible to create something like that? So that's pretty much how we try to look into material.
So sorry, just last question.
Yeah.
I mean, from what I saw to know, I understand there's a strong intent behind whatever design you showed. But given it's computational, there's a lot of repetition in the geometry, right? Have you had any problem bringing, like balancing the aesthetic of the geometry with how it's going to get executed?
Yeah, that's a problem that we face every time, honestly. So because, But honestly, when we start designing, we start typically with a sketch or an image sometimes, which is sort of taken as an inspiration. We try to sketch out an idea. Computer comes at the second stage to help you realize that geometry in a computer, in a digital framework. And often when you create geometries, they're mostly different. So there is a differentiation in geometries. So for example, if we have 20 different fins on a facade, most of the time our 20 are not going to be the same. So they're all going to be unique. So there might be a shift in angle. For example, 40 degree, 42 degree, 44 degree, 46 degree, etc. Right? So when we have to fabricate this, there is a different kind of information that we have to pass on to the fabricator. So for example, I will not tell the fabricator, please make the angle at 46 degree, because he will go wrong in that. I would rather give him the XYZ coordinates of every single point to follow. The angle will automatically come. It's just a simple example I'm giving you. So every time we're working with a fabricator as well, it's mostly, we have to give them the different kind of an information. So a lot of times we have to train the fabricators as well, and that's pretty much why we execute our own facades as well, because that allows us to actually have more flexibility in executing things. Cool. So I think getting back to the presentation, yeah, there is a little walkthrough. If you can pump up the volume as well. Can you pump up the volume? All of this is sort of assisted by AI when we were designing this. That's like the trivia I'd like to tell you. So I think the volume was an issue on this. But anyway, so this was when we were trying to reinterpret Krishna. We made some installations using the Basuri of Krishna, and all of these things sort of coming in together. Can you move to the next slide manually? Yeah. So this was another installation that we designed. So again, this was more of flower blooming, and this is going to be made in metal as a blooming flower, as a part of the landscape with the background of the temple. This is a column design that we did with the peacock inspired column. This is again a Krishna inspired seater, where you see sort of an abstract Krishna with a basuri sort of merging into a fluidic geometry, which is being done in stone. This is another feature installation. So we're doing a lot of art installations for the temple to sort of make it absolutely unique in its own way. This is again a Krishna made with drops of metal balls. This is another interesting project, the Bharat Mandapam, also the Pragati Maidan Convention Center in New Delhi, where we were involved and associated from a very analytical point of view. It had a 10,000 seater auditorium space, and we were given a challenge. We were not the designers for this, but we were given a challenge to value engineer the visibility of an auditorium. That how do we know that within 10,000 seats, which seat is the best? So how did we do that? We actually created an algorithm that would place a human being on every single seat. It will throw, let me explain you the algorithm first before I show you the video as well. So it's like I want to analyze which seat is the best amongst the 10,000 seats or these seats that you have. So I'll place a human being over here. I will throw certain visibility rays onto the screen. If the visibility rays clashes with a person sitting in front of you or diagonally in front of you, then it's a cross. If it passes through to the stage, it's a tick. Simple, very simple logic. But imagine throwing 100 rays from 10,000 seats. So you're talking about 1,000,000 rays being computed in real time. And at the same time, telling you which seat has maximum percentage of rays hitting the screen. So how do you analyze that? So we actually built an algorithm wherein we use the tool Grasshopper to make the entire 3D model where every single seat was designed and made. And this is what the algorithm in running looks like in real time. Just fast forwarded a bit. But yeah, every single person is being seated on the seat. And you're getting a value and also a color of green or yellow or orange or a red, depending on if it's a bad seat, and every single seat is being analyzed and eventually leading to a scoring. So there is a scoring matrix where we have evaluated the entire seats of the stadium, and we know the black seats are the worst, red seats are the bad ones, orange is decent, yellow has some problems, but green are the best. And it's not like only the front seats are going to be the best. There are front seats which are orange and yellows as well, because of the angle of it or diagonally clashing the rays. Now, when we build this algorithm, it could allow us to deploy it in different projects. We actually used it in Yashobhoomi in Dwarka as well, where we were also involved to do a similar analysis. And at the end, it exports all my data into an Excel sheet. And this project I'm talking about, this was done back in 2020, I think, 2021. I mean, this is pre-AI era. Let me just clarify that, which is what I want to tell you. That there's no AI involved in all of this thing. This is all manually written algorithms computed onto a system to calculate all of these things. And this is where we think we are able to make systems smarter. So you come up with a problem, every problem can have an algorithmic solution if you are able to focus on the system. But behind these algorithms, of course, there are processes that are followed. We do have site interactions. We have the sketches. There is a conventional architect and a designer working on the site, which is me and my team alongside, where we sketch, we ideate, we trace, we take it to the site, and all of that conventional process also exists. The reason I want to show you all of this is that it's not only technology. Technology is only a tool that can help you achieve what you're trying to design. That brings me to the next chapter, one of the most important ones for the current times, artificial intelligence. Now, how many of you use AI? Give me a show of hands. I was expecting a full, show of hands on this, because AI is something which is forced onto us, which is permeated into our life in different ways where we don't have any control. Like it's there on Instagram, on WhatsApp, on Facebook, Meta, whatever tool we are using, chat GPTs and lots of things that we are using. AI is everywhere. Somehow AI is also making people look very smart. Smarter than they are, actually, sometimes. But what exactly is AI doing to architecture and design? AI does allow you to actually ideate certain forms by using generative AI, by creating visuals, which might be very appealing, which may or may not be possible to build, but AI is showing us that conceptually. And what we're trying to do right now is we're flirting with AI, knowing it's dangerous, but doing it anyway, trying to understand. And obviously it is changing everything. Previously we were glued to our phone screens like this. Now we are glued to systems like this, trying to create different images and writing emails and whatnot. But let's not blame technology for this. There has always been something which we've been glued to, be it a newspaper or a tool or a smartphone. So nothing to blame with technology, but what we need to think about is that are we designing AI or is it designing us? Because AI is sort of provoking us to do certain things. And let me give you that example through a very recent trend in AI design world that followed, which is called a Ghibli style. Ghibli was an artist whose style got replicated in the AI data sets. I'm assuming everybody basically knows how AI works. And anybody could create this Ghibli style image. So that was sort of a copyright infringement and an ethical issue as far as the art is concerned. Imagine you have an artistic style And now anybody using AI can create that style. So your style is not there anymore, which is exactly what was happening over here. And it actually ended up into a lot of debate as well, that what exactly is AI able to do. And online, if you go, there are lots of prompts now available which you can use to create an image, write an email, or whatever you want to do. There are a lot of architecture prompts available. This is like an AI based Taj Mahal when the AI was not advanced. If you use it now, AI is much more advanced. It will give you much more accurate and realistic Taj Mahal photo. I can just stand like this and place myself in front of Taj Mahal just by using AI in 5 minutes. So all of that has become possible. It has its own problems as well. But what I want to question is, if AI can recreate our style, did it outsmart us? That's something that we need to think about. Because we are not just prompting, but we are provoking AI to do something. And another big question is, are we designing with AI or are we designing for our own replacement? Now that is something which obviously every designer needs to think about. Because yes, AI is there. It is creating better designs, better looking designs, maybe not better performing or better creative, but better looking designs for sure as of now. And that brings me to the next chapter, smart labs. Now I mentioned about smart labs earlier, but what exactly are we doing in smart labs? Currently we are in the 12th batch of smart labs. We started in 2017 from Coimbatore, like I mentioned earlier. So what we've done over the years is we built a team of tutors who alongside me teach different technologies of design. I myself teach Grasshopper. There is someone who teaches Rhino. There's someone who teaches AI. There's someone who teaches Python at times. Someone taking Maya, and there are different softwares. So we have had a team of tutors which keep on changing and refreshing over the years. Many of them are located outside of India as well and teaching online. And we have a global cohort of people who over the years have been using technology, and very recently as in 3-4 years back, I would say 2-3 years back rather, we started to integrate AI into our curriculum. So our curriculum was mostly about design technology using Grasshopper, Rhino, Maya, etc. Very recently we started to use AI, and this was the result of the students who had no exposure to technology, who could leverage AI to use it in the right way to create things like this. This was a sacred space project, a temple being designed by a student. This was a skyscraper in Dubai. I'm just going to quickly brush through these visuals for you to absorb and understand that how AI assisted in creating all of these workflows. And this was all done by students who were taught AI in a matter of 2 hours, 4 hours, etc., who could end up creating results like this. And that did not replace them. That empowered them that what else they can do using the tools and technologies. These are all renders, designs, whatever you want to call it, done by AI completely. Obviously with human prompting. So what we teach them is how to prompt in the right way, to develop their soft skills and their hard skills in AI. So it is not only writing an email using ChatGPT, but it's more about creating a design where they are actually understanding the proportions, materiality, and feeding in all of this information to get the desired results. If you can kindly click on this, I think this is a video. This is a very short video. Or you can skip next as well, if it hangs. Maybe you can skip that slide and move to the next. That's fine. We're almost at the end of it, so let's get back to presentation. That's fine. Yeah, maybe once that gets troubleshooted, we can continue with the Q&A round as well. Yeah. Yeah.
and the structural part of it depends on the material that we use, and accordingly we design or restrict ourselves. So
Right.
I was a little concerned, why are we not actually integrating it, and how does that affect the design
Right.
process?
Okay, so it's not like we disregard the material completely. There are different layers of complexity, like I mentioned. So we have to break down the layers of complexity into simple layers. So the first layer is geometry, second layering is material, and first couple of layers are all intertwined. So it's not like we're not thinking of material. At the back of our mind, we know at times what material are we going to be using for a particular system. So it's not like we become completely blinded by the geometry itself. But yes, geometry becomes a key solver, problem solver, because that is the most complex problem we are trying to solve. So we have to write the algorithm to resolve the geometry so that it becomes buildable. And between that, somewhere lies material. That which material we can use to make it buildable. That's where the material science and the value engineering comes. So it's just the layering of the process, because a lot of times we get asked that we want to do a metal facade, or we want to do a stone facade, and my first response to that is usually that let us play with the geometry first, let us conceptualize a design, then we'll see what material we're going to be using. At the back of our mind, I know it's going to be a stone facade. At the back of the mind, I know it's going to be a metal facade. But at this, I'm focused on the design part, because I feel that if you don't break down the complexity, you're not true to the process, you might end up having something else.
Okay, I understand what you mean, but from all the slides that we have seen so far, majorly the facades have been metal based.
No, they look metal.
Okay.
They're not. Yeah.
So
There have
what
been-
would be the percentage of? I feel like the metal, since you mentioned it's more versatile compared to
Right.
other materials, so it would be an easy choice and a prominent one.
Metal is cost effective.
Huh.
It's easy to maintain. Whenever we do facades, there is a maintenance aspect that is very, very important. So when we are doing a residential facade, it's usually plaster and concrete and all sorts of regular materials, brick and concrete as well. Even that curved facade that I showed at the earlier for residence, there was no metal used in that. It was all simple RCC structure basically. So metal is usually for commercial projects, and we end up working on a lot of commercial projects where the requirement is maintenance is a key aspect basically.
Okay, thank you.
But then there is FRP, GFRC, glass reinforced concrete. All of these materials are now coming up because they can be molded into any shape as well.
Got it. Thank you. And one last question. So since this is geometry based, how much do you integrate sacred geometry into this?
Yeah, so like the divine spaces, the ISKCON temple and the Sai Baba temple that I mentioned, I think we were looking at not the geometry, but mostly about the experience first, honestly. So it's not like the computer is going to solve the problem of creating a design for us. We have to think of the experience ourselves. And that is something which is to do with a lot of research about the subject. For example, if we are conceptualizing about Sai Baba temple, we have to understand, we did a lot of case studies on temples to understand how do people experience the space, how do they move in space, what is the kind of materiality, tactility of the space as well. Same goes for the ISKCON. The philosophy of Krishna was more big as a time consuming exercise for us in a studio than creating that space, for example. So experience comes first, typically.
Thanks.
All right, so yeah, again, this is another student project, which was again assisted by AI to actually create the visual as well. This was the Dubai skyscraper project, which is again, we use AI to generate the design. 3D modeling was done conventionally using computational techniques. Then AI was used to sort of help in the rendition and the visualizing. Then the videos were also done using AI, where you could actually program your cameras to in a certain manner. So you actually speed up the storytelling process a lot more. And this is where we feel we are able to utilize AI in a much better way uh, than how people are conventionally using AI as. So Smart Lab has been a good playground for us where students have been very experimental, very innovative in nature. And yeah, these are all digital fabrication experimentation. Some students end up creating apps which have the interactive design module, 3D printing, creating buildings, forms. All of these are done by students across the years, students who come from second year, third year, fourth year of architecture typically. And they come with zero idea of technology, but they are empowered with these tools that they can end up creating things like these. And that has led to sort of a great revolution for us in its own way. Uh, we've had more than about 250 plus students graduating in the last 11 batches, 12th batch is going on, 13th batch is coming soon in September. So every year we try to do one batch of 6 months. It's a hybrid program. Anybody from any part of the world participates in that. Now it's mostly online, and few physical studios we have where we teach them about digital fabrication, 3D printing, how to set up your files, how to work with a laser cutter. And at the end, they work on a very exciting exhibition. It's a more hands-on exhibition where they put in all their works together and present that to the public, to the outer world. So these are all outputs of that. I'll quickly show you some more works of AI integrated with computational design. What you get out of AI, you end up 3D modeling all of that as well. It's not like you stop right there. So students are encouraged to 3D model that using the tools that they've learned, Grasshopper, Maya, Rhino, whatever tools. And the kind of design complexity that the students are able to achieve through this is kind of commendable as a batch what we've seen over the years. And as a studio director, it gives me a lot of satisfaction as well, because we're able to train these minds for the future. And we've had like people from different cities and different countries over the years who've been a part of it, different mentors from different parts of the world. So this has been sort of a different school in itself. There's a short video which shows you, if possible, we can have the volume in case, that's fine. No worries, a self-explanatory video where I'm sort of explaining the whole process. This is what an exhibition showcase sort of looks like. So all the students end up putting up their work, presentations, they learn different kind of skills through these 6 months. So even if they've attended the entire session online, we encourage them to come for the graduation so they're able to be a part of the exhibition. All the AI-driven works. We also had the principal of one of the colleges in Pune who was there on the screen a while back. Almost a 55-year-old lady as a student, because she wanted to upskill and she wanted to learn. So we always have students of different age groups, from different diversities, different backgrounds, and what they do together collectively is magic at the end of the day. So yeah, that's pretty much about studio. So that sort of brings me to this chapter called EduLab, which is a self-learning lab. So I've spoken about RAT Lab, spoken about Art Lab, spoken about Smart Labs. Now let's bring another lab, open it up. It's the EduLab. So what we are building right now which is currently in almost pre-launch stage, is a lab. We have understood that great technologies are not accessible and affordable to all. So everybody cannot afford or have the access to, especially in tier 2, tier 3 cities, to the right technologies, nor they're guided very well. Obviously, I feel I was very fortunate to do a master's at the AA, be in London and Los Angeles and get the global experience. But how do we give that experience to students? So what we are doing right now is, for the last 12 years, whatever workshops we've done, we have packaged it all to scale that impact to reach out to everyone. So we build a platform where we are putting a lot of the tutorials for free. So everybody can get a basic access absolutely for free, any part of India you're in, till the time you're a student. And then there are other packages as a part of EduLab as well, where we teach computational design, emerging technologies, AI, how to do design research. All of these are done into different packages and modules, which everybody is learning. We opened up the waitlist, I think a couple of months back, and we've had a great response on that. So in case anybody wants to learn as well, you can just go to edulab.in and just put your name in the waitlist. As soon as the courses go live, you will get the free access to it, so that we can sort of try to empower you by using these tools, and you can learn them as we build them in chapters. And that brings me to the last chapter, the algorithm versus the human mind. I started talking about the algorithm. You've understood all sort of works that have been produced by the algorithm. And how does the human mind comprehend? Like I mentioned earlier, it's all a system. If you focus on the steps, if you focus on the sequence, every simple problem, every complex problem can be solved, which is what we try to do. We try to tackle the complexity in a different way, that we don't ignore complexity. We try to focus on the system, and that is what would bring a clarity onto a system, which is what I want to get back to the analogy that I started with. That has something changed? Because through the sequence of steps, what you would notice is a salt cube. And I never focus on the complexity of the problem. I never focus on that number. I focus on the sequence, I focus on the steps. Subconsciously, mind is trained, hand are trained, only in a short span of time. And that allowed me to solve the problem. Which is what I would say, that great designers don't eliminate complexity, they learn to navigate it. And the difference between magic and an algorithm is the understanding. So this is not magic. This is basically purely an algorithm being able to solve in real time. Thank you very much. Can you get back that slide? I have one last slide for everyone as well. So yeah, if you're an interior designer, if you're an architect, if you want to learn, these are the platforms to follow. These are the tools to follow. Maybe you can snip it up and get in touch with us as well. Obviously, a lot of our work is about working with students. A part of our work is working with interior designers for their art installations. A lot of our work is with architects doing their facades and different kind of complex problem solving. So this is what the laboratory does. And a laboratory is all about experimentation, and this is how we solve the problems. So happy to take any questions that you guys have.
I was curious about the sculpture installation at Kochi airport you did, no?
Right.
The butterfly one and the Krishna balls.
Right.
So when it comes to two-dimensional, like the Kohler wall paneling, the numbering matters, and if we follow that numbering system, it is easier to install. But then when it comes to different angles and different directions, how would you execute it?
Right. So it's a problem of solving the angles in different planes. So when we are working three-dimensionally, like how one butterfly is stuck to each other, for example, or welded to each other rather, It is all about solving the problem. So in that particular project, if we had 200 butterflies, so how we solve the problem, it may have different solutions. We had to put a flight of butterfly as if they're like taking a flight basically, right? So eventually everything is in the air, but at different angles. So for a fabricator, it's not easy to compute the angle at different phases. So what do? So we created a mold out of it. So what we did was we designed a surface, we contoured the surface in both the directions to make a mold of ply, which becomes the Verma, for the fabricator to just start placing the butterflies. And we gave him a rule. That the rule is that the biggest butterfly goes with the small butterfly and the medium butterfly. There were like 5 kinds of butterfly. So A, B, C, D, E. A will go with B and D. B will go with C and D. Just follow that rule. And if we kept on following that rule and just kept on welding without thinking also, it ended up creating that form. And that's exactly how we solve every problem as well. For the installation of the Krishna, where the hanging metal balls are there, that is a problem of the XYZ position of each metal ball in 3-dimensional space. So that is to do with the correlating length of each string. So if each string is numbered and has the length defined, that's all you need. So I think it's all about understanding what is the information you require to translate an idea into reality. Sometimes that information is a lot of numbers. Sometimes that information is a set of rules, how things come together. And that keeps on changing project to project.
Any other questions?
Hello. I was just wondering, like, there are a lot of complex geometry involved in most of the designs. How do we make it more cost effective, especially when we are talking about those individual residences and the Sai Baba temple where it's out of concrete, the form work and everything? How do we make it more cost effective and also more adaptable in terms of time constraints?
Right. So these are very much real life problems that we face because like I mentioned earlier in the talk as well, that whenever we do something, it may look complex. But the actual challenge and the role of a designer starts at how we have to break down that complexity into simple parts. So one of that is cost. So how do you control cost? We break it down. What are the materials used? How is the material translated? Wherever there is a complexity involved in that process, we break it down into simple methods. So it's very hard to say, in a very short span of time, how do we solve it? But there are a lot of parameters that we look into about how the fabrication is done. If a particular angle is a problem for fabrication or casting concrete in a different angle, we will change the design. So design system is going to be fed with that information to change that particular form. And in that particular Sai Baba temple, for example, once it gets executed, let's say, it's a modular system. So there are 11 modules of each geometry. So if those modules can be built in parallel and assembled together, you are saving the problem of time. If you are using RCC molds and you have punctures in my geometry, if I modularize the punctures and they are not different sizes, I'm able to help the cost. So these are strategies that we end up using. So a lot of times it's about conventional understanding how you would bring down the cost of any project. You will actually open a BOQ or an Excel and look at what are the items which are costing more. Same process we follow. But yeah, we have to break down the complexity to make it more cost effective, because otherwise the project doesn't become feasible. Unless there is a project which comes with a vision that it has to be of a certain level and the cost is not a constraint. But in India it doesn't happen, unfortunately.
Does anyone want to ask questions? The last.
So, good evening. So, you were talking about a lot of various analysis you do before you come to an conclusion about your design.
Right.
Is there any assessment that you do considering an impact on an environment or a habitat that's surrounding your project, or any calculations that you do that minimalizes the assessment or impacts that's happening around the in and around the projects? Is there anything that you do or to be considered regarding that?
Right. So it truly depends on the kind of project. If I don't think there is a project, and I'll be very honest with you, there's a project where we think about the surroundings in that aspect, that what happens to the surroundings, because the client only focuses on their project ideally, right? But the environmental response is very, very important. So a couple of analysis which we always do is radiation study. How does the solar radiation hit the building and the volume basically? And accordingly, we would design and orient the building or design the facade accordingly. So that becomes a very important aspect. And that is something which pretty much in all the facade projects we would consider. So apart from that, materiality is usually something that we like to think about. It should not be a material source from somewhere very far, for example. There are times, there are projects where we have a specialist as a consultant, as a passive design consultant or a sustainability consultant, who looks into all of these parameters as well, in case the building is going for a LEED rating or a GREHA rating and those kind of things as well.
That's saying, does it even do that climate analysis kind of a thing, right? Because the materials that you use in a facade.
Yeah.
So again, the climate analysis also, does it play a major part in your
Yeah, absolutely.
designing?
Climatic analysis is almost a must in all the projects actually. That's something we look into. We look into the daylight aspect, the lux levels, we look into the radiation study, how much of kilowatt hour per meter square of radiation is received by the building. Accordingly, the materials are decided, accordingly the geometry is decided. How does the geometry help cut down the heat, unnecessary heat? The cooling load should be reduced down. So we look into the HVAC person as well, and lies with him. So all of these aspects are looked into.
Sorry, this I'm not really us, but some of us are academics. Okay. Now, one of the problems which we are facing is uncontrolled use of AI.
Right.
Now, what would be your advice?
Yeah, no, that's a very, very relevant question and a very relevant problem actually. That is happening, very hard to control. It's almost addictive. I think the only way to control is to channelize it in the right direction, which is what is very required to do. So the only thing that we can do is create more education around it. How to use AI in the right way. Because if we don't do that, it's always going to be used as a weapon in the other direction. So that's what's happening right now, which is what we also started to do. Like I mentioned, that we introduced AI into the curriculum a couple of years back. At that point, we were like, we don't want to use AI because AI is rubbish. Like people are using it in a very random way. So how do we control it? So we inculcated that into the curriculum to teach them how to use it in the right way. And it was the experimental approach. And it led to a good result. Eventually, over a period of time, those designers or students who were using AI, they started to get acquainted to use it very, very diligently and responsibly. We talk about the ethics of AI as well. We talk about if we are using a Zaha style or a Norman Foster style or a Gehry style, you have to be conscious and knowing if you don't know how to build it, don't use their style. Simple as that. So people become more conscious. So I think, long story short, I think it's about channelizing it in the right direction. That's the only way, unfortunately. AI is dangerous as well.
The last question, can we have a workshop in future if we want it in Coimbatore?
Yeah, sure, absolutely. We can plan something out.
I think everybody
definitely.
would love to have you.
We'd love to share our knowledge with everyone.
Thank you.
Yes.
I request Architect Balakrishnan sir to please come to the dais.
Okay, wonderful. Yeah, okay. Thank you so much. Thank you. Thanks a lot.
I request Architect Nagapan to deliver the vote of thanks.
Good evening all. I would like to thank the guest of today, Architect Sushant, for a wonderful presentation. The full house today is an honor we have done to him. Thank you guys for attending in big numbers. I would like to thank the event management partner for a wonderful stage setup, Tudor Media for all the photography and videography, and Radisson Blue for all the hospitality. I once again thank all the members who have joined us today. Please join us for dinner and cocktail. Thank you.